Hi! Today, we'll be reviewing how to complete a pupillary assessment and determine if an afferent pupillary defect, or APD, is present in a patient. Let's start with a quick review of the eye's normal response to light. In dim lighting, our pupils open to allow more light into our eyes, so that we can see a little bit better. But in bright light, our pupils constrict to limit light exposure and protect the sensitive retina from damage. Okay, but what's really happening behind the curtain, aka retina? Let's zoom in. This is the visual pathway. Sensory stimulus from the light travels into the eye, hitting the retina. The retina transforms that stimulus into a signal, and thus begins the afferent pathway. After leaving the retina, the signal travels back along the optic nerve to the optic chiasm. At this point, nasal signals decussate and temporal signals remain ipsilateral as they head to the pretectal nucleus in the midbrain. Here, the efferent pathway takes over, sending signals from the Edinger-Westphal nuclei down the ocular motor nerves to the pupillary sphincter muscles, causing both pupils to constrict at the same time. Alright, now let's put this to the test. To assess the pupils, start by checking the size and shape in normal light. They should be equal and round. Time to turn down the lights. Geez, super dark. This is important to allow the pupil to relax as much as possible and get an accurate reading. Next, check their reactivity to light. Shine the light into one eye, checking for the direct response. Remove the light and wait for the pupils to relax again. Apply the light again, but this time watch the opposite eye to check for the consensual response. Alright, good. We're going to repeat that on the other eye. Note, the pupils should both react briskly and equally to the light. Finally, use the swinging light test to check for an APD. Move your light back and forth between the two eyes, ensuring to pause on each eye, and then move briskly across the bridge of the nose. In a normal response, both pupils constrict equally no matter which eye the light is in, as seen here. With an afferent defect, both pupils will paradoxically dilate when the light is over the affected eye, and then constrict when the light moves back to the unaffected eye. An APD is a clue that a serious ophthalmic or neurologic concern is present. The pupils dilate because the brain thinks less light is coming in than there actually is. This mismatch can be the result of many things, with a handful of things listed here. Pupil assessment is a quick and powerful tool for spotting pathologies that are essential to catch early. Here are some key takeaways. Remember to evaluate pupils in dim lighting. Use a bright and focal light to avoid any spillover. Be sure to check size, shape, and reactivity. And use the swinging light test to detect for an APD. And that's it. You are now an expert in assessing pupils.